We're on the last few pages of chapter 2, and we're looking at inequalities. I've put some of the inequality symbols on here. This would be a less than or equal, greater than. I wrote less than or equal to again. Oh man, I just realized these need to be fixed a little bit. Oh, cool. Um, let's look at this. We should have less than or equal to, greater than or equal to, and then less than, and then greater than. There we go. That looks much better. And then we have the not equal to symbol right here. I always had a hard time with this when I was younger, trying to figure out what was a less than symbol and what was not. And a less than symbol, if you fold it out, it will make an L, and L stands for less than. When I was learning this growing up, people always said the alligator eats the bigger number, and I guess that could work also if you ever have a hard time with this. You can put an X on one side and a Y on the other and read it from left to right, X is greater than Y, and figure out that this is a greater than symbol, if you felt like that was something you needed to do. It's not unusual for an inequality to be set up unsolved, and your task is to solve it before you can express the set of numbers that it represents. If you solve an inequality, remember if you multiply or divide both sides by a negative number, then you must flip the symbol. Flip the symbol. It only happens if you multiply or divide both sides by a negative number. So whenever you're working with an inequality, you basically need to solve it. Everything else you do is like solving an equation, except just keep an eye out. If you were to multiply or divide both sides by a negative number, then you have to flip the symbol. And then you have to figure out how to express the solution, because there's several different ways you can express the solution to an inequality. And the first method is to just write it as an inequality. For instance, if I had something like x is greater than 3, I am expressing the numbers that start at 4, 5, 6, until infinity. There's infinitely many numbers I could plug into here. Not all of the numbers would work, but the numbers that are greater than 3 would work. That's one way. The second way is to graph your answer on a number line. Notice that there are different kinds of bullets you can make here. We call them, one is a closed circle, one is an open circle. A closed circle indicates that you are going to be equal to that spot, and then an open circle is implying that that specific number is not part of the solution set. In this case, x is greater than 3, it's not equal to 3, so I'm going to put an open circle on 3. And this is greater than, so I have to draw an arrow pointing to the direction of all of the solutions. You can see there that that's how I would graph that on a number line. Last but not least, we also have interval notation. I think we've seen this in the past with talking about domain and range. For this one, we're talking about going from 3 to infinity. 3 is not included, so I would use a set of parentheses. Remember that parentheses are used for when that starting point is not part of the solution set. 3, comma, to infinity. Whenever you have infinity, you always have to put a parenthesis next to it. How would this look, though? If I had x is greater than or equal to 3, then what that would change about this interval notation is it would start with a bracket instead of a parenthesis, because that would say that 3 is included, because I could put 3 here and it would still be correct. But that's the kind of situation that would have you use a bracket instead of parentheses. Here are a few different examples of inequalities, and on these you have different ways that it's asked that you display the answer. So for this first one, A, which I'm going to do with you, it says to express your answer on a number line. Whenever I am solving an inequality, one thing that I always do along with my equations is I draw a line where the symbol is, to remind myself that whatever I do on one side of the line, I have to do on the other. So I'm going to subtract 7. Got to do that to both sides, which leaves me with negative 5x greater than or equal to 15. I did not flip the symbol because I just subtracted a 7. I didn't multiply or divide yet. To get x alone, I'm going to have to divide both sides by -5. Divide by a negative, that means you must flip your symbol. And there's my answer. This is expressed as an inequality right now, but if I was going to make this on a number line, I would make a number line that has -3 on it, because that's kind of important. I'll put a couple other numbers. It's going to have to be a closed circle, because it says equal. And this is all the numbers that are less than or equal to -3, so my arrow is going to point this way. There we go. Let's look at C. So I'm going to do C with you. I have b over -5 is less than or equal to -20. Anytime you're trying to solve and you have a fraction and you want to get rid of the fraction, you can multiply the pieces by whatever is the denominator. That will allow you to cancel the denominator. The thing is, I'm multiplying both sides by a negative, which means I have to flip the symbol. There is my answer. B is greater than or equal to 100. And 100 is included. So I'm going to hit a bracket. If it's greater than or equal to 100, it starts at 100 and it goes to infinity. There's interval notation. This first one was expressing on a number line. There are four more examples for you to do. This is where I'm going to ask you to pause the video. I want you to do B on top and then A, B, and C on bottom. And then you'll come back and compare your answers with what I have. Okay, so here we have some answers. I did B first. It's possible to have a fraction as part of your answer. There's no rule about that. I started by subtracting 3w from both sides. Then I subtracted 15 from both sides and divided by a +9. This is expressed as an inequality. I didn't have to do anything else to show that answer. The next one, I had to subtract 12 from both sides and divide both sides by a +4. I left my symbol the way that it was. I have to express my answer in interval notation. X is greater than -1/2, so parenthesis, -1/2, all the way to infinity would be the correct answer. I could plug those in for X and be true. B, I subtracted 8h from both sides. Then I subtracted 1 from both sides and divided both sides by 2. I didn't have to flip any symbol, although at the end I did rewrite this so that H started it off instead of in the second part. As long as my alligator is still eating H, I can change the order. I can change this around. This says 4 is less than or equal to H. This is H is greater than or equal to 4. It's really the same statement, just said two different ways. I like this because this helps me do a better job at creating the number line. It's just the way I see things. And then for C, add 8 to both sides. Multiplies both sides by -3. That meant I had to flip the symbol. M is greater than -54. This is expressed as an inequality, which I did. Now let's look at graphing inequalities, because we have graphed lines, we haven't graphed inequalities. There's only two more things to consider when you're graphing an inequality. You still have to plot the y-intercept. You still have to use the slope to make more points. But now you have to decide on what kind of line you're going to draw. If you are drawing a broken line, that means that you are using either a greater than or less than symbol. So this is essentially the same thing as a hollow circle. If you have a greater than or equal to or less than and equal to, then you are going to draw a solid line. So that's a big thing. The last thing you need to know is whether or not you should shade up or shade down. So shading is the next thing. You'll see on here that there are some examples of these steps on here, but if it says less than, that means shade down. And if it's a greater than, that means you're going to shade up. So let's try this real quick. I'm going to start with the y-intercept -7. 1, 2, 3, 4, 5, 6, 7. My slope is rise 2, run 1. This is a broken line because there's no equal. So when I draw my line, it's going to be a dotted line. And then this says less than. So that means I have to shade below. And this is what it looks like when you solve or when you graph the solution to an inequality. If you ever want to check your work, you can pick any point that's in the shaded region. This is 1, 2, 3, 4, 5, 1, 2, -3. So this is 5, -3. If I were to plug this in to my equation, it should give me a true statement. Is -3 less than 3? Sorry, I had to look at that. Is -3? Yes, that's true. So this is part of the solution set. The solution set is that shaded region. For B, we're going to go up 6 units. 1, 2, 3, 4, 5, 6. There's my y-intercept. I am going to do the rise and run 3/5, although I have a negative, and I'm going to put the negative with the top. I'm going to rise -3, run +5. I can only do 1 point because my graph is limiting me. This is going to be a solid line because there's an equal there. And this is saying less than, so I have to shade below the line. There it is. It's possible for you to be just given a picture of an inequality that's graphed, and you have to write the inequality out. So remember that we're still doing the y equals mx plus b thing, but it might not be an equal sign here. It might be a less than, greater than, whatever, one of those. So for this first one, I can tell you that this is dotted, so there's not going to be an equal symbol in my inequality. This is shading up. So that means y is greater than symbol, no line underneath because this is dotted. Y is greater than. My y-intercept is 6, so I know I'm going to plug that in for, if I'm writing this out, I'm going to plug 6 in here for B. I have to figure out what is my slope, so I'm going to pick this point here because it's perfectly on the grid lines. It looks like I'm rising 3 units. If you look at the units here, they go up by 3, and then I am running back by 6 units. So my slope is rise over run. My slope is -1/2. So if I write the equation for this line, it's y is greater than -1/2 x plus 6. Let's look at the next one. I'm going to start with y. This is greater and equal. Greater is shaded up, equal because it's a solid line. It looks like my y-intercept is -6. It looks like my slope, if I were to zoom in here pretty good, let's go right here, rise 2, rise 4, 1, 2, 3, you're rising 4/3, 4/3x minus 6. You have to really pay attention to the units on the x-axis and the y-axis to make sure you're honoring them when you're counting rising and running. The last part of this section is looking at graphing a system of linear equations. And so you know in the math context, a system means that you are trying to solve more than one equation at the same time. I'm going to come back to this one in just a second. I'm actually going to go to the next page, and then we'll come back to this so you can see something in a little bit better of an order. Here is the example on page number 4, where basically you're given 2 equations that are in general form. It's important to know you have to put these in slope-intercept form before you can do anything about graphing them. y is less than negative 2/5 x plus 3. That's this first one. The next one, 3x minus 2y is greater than 6. Subtract 3x from both sides. Negative 2y is greater than negative 3x plus 6. Divide everything by negative 2. If you do that, that's great, but you're going to have to flip the fraction, flip the symbol, sorry, not the fraction, the symbol, because I divide by negative 2. 3 over 2x minus 3. Holy Hannah, it seemed like a lot of work. It is kind of a lot of work. I'm going to start by graphing this one. Go up 3 units. Rise 2. Run negative 5. Dotted line. This says greater than. Now I'm going to do this one here. Negative 3 is my y-intercept. Rise 3. Run 2. Dotted line also, because it has no equal. And less than is right here. So my solution set is going to be in this spot right here. This is the solution right here. Again, if you want to test out your solution, you can always take one ordered pair out of here and make sure that it makes both of those equations, inequalities, true at the same time. So lots of stuff in that section for the little amount of time that we had. But hopefully you won't have too many issues doing this on the homework. If there are questions about graphing or anything, just post to me and I will do a video example of myself doing the homework in WebAssign. Okay. Okay, so here we are at this page. I want to look at C. These are in slope-intercept form. I'm going to just graph this first one by going up 2 units and making my y-intercept. Rise 1, run 3. Rise 1, run 3. Solid line. Why is it a solid line, you ask? It's because it has an equal symbol. This is y is greater than, so I'm going to shade up. I'm going to change in my color. Now my new y-intercept is 7. 1, 2, 3, 4, 5, 6, 7. My slope is negative 2/3. Rise negative 2, run positive 3. So here we are, solid line, because it says equal. And this is y is less than or equal to, so I'm going to shade below. My solution set actually happens where the shading overlaps. So it actually happens right here. We would call this the solution set. Usually what you do if you were doing this on paper is you would put an S there to indicate that you know that's the solution set. There are different situations that can happen. For instance, I'm expecting these to be parallel lines because they have the same slope. For the first one, if I go up 5, 1, 2, 3, 4, 5, it says that my slope is negative 1.5. If I convert that to a fraction, it looks like that. So rise negative 3, run positive 2. There it is. Solid line, because it's got a equal. It says y is greater, so I'm going to shade up here. I'm going to change my color. Y-intercept is 2. Slope is the same, negative 3 over 2. Line type is the same. It's solid because it has an equal symbol. This one says y is less than, so I am going to shade less than. I want you to notice that there's no overlap. No overlap means no solution. No solution. I'm going to take us back to the page before this.